Alright guys, I'm Kevin.
I'm Monica.
So for our project, our goal was we're going to make some chromatography resin. Well, what's chromatography resin? Chromatography resin is basically, it's a really tiny picture here, but you want to separate some proteins from a solution. That's kind of like a big part of making drugs and whatnot, and for pharmacy and stuff, you have to purify, make sure that you have just what you want in it, and get rid of everything else. The thing is, what they use to bind to the proteins is bio-nanoparticles. These bio-nanoparticles crush under any amount of pressure, which means that if we put them in a chromatography column, they would get crushed, and they would just form a gel, and it wouldn't really help. Everything would just form a gel, and nothing would separate. So what we decided to do was make a scaffolding that's going to help protect and encapsulate these bio-nanoparticles. It's just going to be a little plastic bead that's going to hold the nanoparticles inside of it, and then as the solution flows through, it's going to bind to those bio-nanoparticles that are inside the plastic bead. So our job is basically, for this company, they were founded in 2014. They do immunotherapies. Our job was to basically come up with this recipe and use this setup that we have kind of going on right here to make little plastic beads that are about 50 microns. That's about the size of a grain of sand. We have some samples right here. Kind of hard to see, but it's little plastic beads in there. A big part of this project was developing just the experimental setup and kind of figuring out how to make beads that are the right size. Two of the big problems we had in our project was the size of the beads, and we got all the beads that stick together. So one of the reasons we also did the plastic beads was because the bio-nanoparticles themselves stick together. But then we got the plastic beads that held the bio-nanoparticles, those started sticking together. So we were kind of back to square one. We tried changing the different surfactants and stuff to get them to not stick together, but we ultimately were not successful with that. We were able to produce some beads though that stuck together, and we figured out how fast we needed to spin this impeller to make beads the right size. Some of the results, we got a lot bigger than expected based on previous work with polymerization science, and that was because the beads kept sticking together. Eventually, we got some really good scanning electron microscope images, and we found that they were about the size that we expected in this graph. So that was really exciting, and we got a recipe that looks like it should help the company move forward and be able to produce some encapsulated particles inside a plastic bead.